Polynomial function is any function that fits in the form f of x is a sub n times x to the n power plus a sub n minus 1 times x to the n minus 1 power, a sub n minus 2 times x to the n minus 2 power, and so on and so on and so on. The powers are going to decrease until you get down to x to the first power and then a term with x to the 0 power. Now anything raised to the 0 power of course is 1, so you can just write that last term as a constant. Now polynomials, we can talk about the degree. The degree of the polynomial is going to be the power on the highest power term. So in this case the degree is n. The leading term is going to be the entire term that has the biggest power. So in this case the leading term is a sub n times x to the n power, and the leading coefficient is simply a sub n. Now these coefficients, a sub n and a sub n minus 1 and a sub n minus 2 and so on, those subscripts on those values, on those constants a, are just to indicate that they may be different numbers. It's not, each of the terms can have a totally different coefficient, some positive, some negative. The one thing that we are kind of picky about, to be able to categorize this, any function, as a polynomial function, in the powers have to be positive integers. So you'll never see a negative power in a polynomial. You'll never see a rational power in a polynomial. Just positive integer powers. And then, whatever the first power is, the next power is 1 less. The next term has a power of 1 less than that, and so on. Polynomial functions written kind of in standard form start with the leading term, which is the term with the biggest power. They don't always have to be written with the leading term first, but if you're going to write them in standard form, that's what you're going to do. Now the graphs of polynomial functions are always smooth, continuous curves. For example, if you have a linear function, that's a polynomial function. Smooth, continuous curve. If you have a quadratic function, that's a polynomial function and is a very smooth, continuous curve. One of the first things that we want to talk about with polynomial functions is the idea of end behavior. Okay, and end behavior is really very simple. It's simply how the graph behaves to the far left and far right. So that's, and basically what we're thinking about with polynomial functions is, if we look at this linear function here, the right end behavior is that graph is going up forever. The left end behavior, if you look at the far left of that graph, it's going down forever. So if I were going to describe the end behavior for this linear function, I would say that the right, and this is how you can do this, the right is going up to positive infinity, and the left is going down to negative infinity. For our quadratic curve, the parabola there, the right end goes up and the left end also goes up. So you have a handout that you need to complete titled Investigating End Behavior, and this is how you can answer those questions. The first function that you're going to look at is, let me pull up my calculator here. Yeah, the first function on your handout, come back calculator, there we go, is f of x equals 2x to the third power. So make sure you follow the directions on the handout about setting up your viewing window. But basically what you're going to do is this. You're going to enter that function in your calculator, take a look at the graph. You do not have to sketch that graph. But then on the handout, I want you to write what is, what's the end behavior for this particular function. So for this one, I would answer this, that the right end goes up and the left end behavior is down. Okay. So on your handout, you're going to answer several questions like that, and then take a look and try to draw some conclusions, and then we'll go over that together in class.